Hi everyone, Diego here. Welcome to our second episode of Convector Developer Office Hours. Uh, so in this topic, we're going to talk about a couple of topics that the community asked in the Discord chat. We talked about a little bit of debugging, a little bit of complex types, um, maybe a little bit of the identity patterns. So welcome, Walter.
So yeah, hello everybody, welcome. Yeah, I think we can start with the first news, which is that we are migrating officially the documentation site to a new domain, and we are changing the way that the life cycle of it is working. Right now, the docs will be at docs.worldcivil.com. In there, we have information about Hurley, about Convector, but also about other products that may be useful for you. In this case, we are, for example, creating a new official tutorial to keep just one centralized that is always going to be up to date because things change a lot and we create new versions of the tools. So for you to have the latest, you can also always go to docs.worldcivil.com, and in there you can access already this new tutorial. In this case, this is a tutorial to build a smart contract system for an attributes database. So this is a different kind of demo that you usually see. As you know already, we have the supply chain. But in this opportunity, now we have something that is different. It also involves companies. It also involves end customers. So you can go and you can check it out. It's again at docs.worldcivil.com. And we will continue to increase this tutorial to be able to include things like Swagger, CoachDB, and that you have been asking for.
Yeah, awesome.
So let's get
I
started.
actually just put the links on the notes video. So if you're looking at the video, you can go to YouTube and click on the description. There will be a link to the new doc site. And yeah, I read the example. It is pretty comprehensive, extends and covers a lot of topics. It's not the usually Marber example, for example. It really a really good example for the community. I think. I hope for everyone that it really makes it clear. And if not, then if you're having any questions or any problems with that, you can always go to Discord and ask us any questions about it. So
Yeah.
yeah.
So actually, we do have some topics that people were asking in the Discord channel. So you remember the idea of this webinar is for you to make questions, to engage with us, to don't stay with doubts, and we will be talking in a lightweight way some of these topics. It may be a hands-on, or it may be an explanation. So the idea is to generate the materials that the community is asking for. So I think that the first one that is around, Diego, is about the Convector flat model. Can you tell us a little bit about that?
Yeah, so pretty much, I've seen some members of the community having a little bit of confusion about what is the utility of this model. So it's basically when you have a model and you have a deep, you have a nested model inside this model. For example, you have a person, and this person has, for example, a car. And for example, you want to store this car inside the person model, just pretty much more what you do on non-SQL databases, for example, that you nest models and you put all the data in a single document. What you will store inside this car field inside this person will not be a reference to an external model. So when you're talking about this model, it's not a full model that has all the save properties, all the fetch properties, all the other methods or utilities that convector model has. So we create this flat convector model, so you can pretty much pass any existing model to this kind of type, and it will make sure in TypeScript to give you the right information about the things that it has, just the plain structure of this model. It doesn't have all the rich methods of a model. And if I may, I'll show an example of this on the screen so it can make it a little bit more clear. I think we're looking on the screen, yeah. So for example, in here, I have the pretty basic Marvel example. I have the Convector test private data repo open here. And let's say that, for example, I want to have Marvel private details inside this Marvel model, for example. And if I go in here and like details, and if I do this, let's validate this, validate Jube, lazy, I think it has to be lazy, Jube. No. Is the schema, yeah. So for example, if we have a model like this, what we're telling it to TypeScript is that this specific details property in here is going to be a full convector model, because this is what Marvel private details is. It's a convector model. But in reality, what we're going to store in here is just the JSON structure of this model, not the entire convector model. And to fix this, and if I, for example, I go here and create a new Marvel, new Marvel, I will be able to do Marvel that details that save, for example. But this is not correct. This is not going to be correct when we start to saving data in this details property, because what we are going to save in here is just a plain JSON with the shape of a Marvel private details. So at the end, it will just contain something like this. Details. Going to be, for example, it has a name. Yada. And a price, for example. At the end, it will just contain this JSON structure. It won't contain the full convector model. So to fix this, what we created is a flat convector model. Flat convector model. We just pass the model that we want to shape and reduce conveniently. So now we get a hint. Now it's telling me that save is not a property, because in this is not a property. What I'm going to start in details is just a plain JSON. So it now gives me the right properties and not much more. So this is pretty much the use of flat convector model, is to help you reduce and properly type the properties on your model when you're nesting properties inside another model.
Yeah, what I think we can tell in a nutshell is that if you don't use or you don't extend the convector model, you will have to do a lot of things by hand. For example, using the decorators and so on. So it's like the happy middle between having to do things by hand and having a full convector model. It's a way to use it and get the benefits, but not confuse the developers. Because if you do what Diego was showing in here, somebody may think that details may be a different model, and they could save this to the ledger, which is actually erratic behavior, right?
Yeah, correct. Yeah, and that's precisely the intention of flat convector model, to don't make you think that you have properties and methods that you don't really have in here. It's like if you just want to have the full JSON structure of this model and not anything else, you use flat convector model to remove all those extra methods.
All right. The second topic that we have in here, and we don't have much time, so we have to go fast. The last time the time flew, so we have to go faster this moment. It says more about Convector platform browser. So maybe, Diego, you can tell us a little bit of what's the benefit of having this package and what does a developer can do with it.
Yeah. Okay. So the browser platform is just meant for mocking up the browser to pretend to be, for example, a ledger. As you know, like Convector supports multiple blockchain technologies. It does not focus on Fabric per se, although it's the only Fabric blockchain technology that we support right now. But we're aiming to add more and more blockchain technologies. The idea of having the platform browser, Bits, Convector, yeah, for example, Convector. The idea to have the platform browser is to give the browser a mock layer, simulated layer, so you can import things like, for example, the browser controller adapter and the local storage layer, you see. So you can work with Convector in the browser without having to need any other external layer. For example, this is mostly for demoing and for testing purposes. The idea to have this is you can use Convector in the browser without you having to import the Convector platform browser. All you need is the client factory for you to use Convector, but you will need an adapter somehow. So this adapter might be an adapter going to a REST API, for example. But in this case of the StackBlitz example, we use the browser controller adapter, which is just a layer to communicate with, to mock up a layer running in the browser and to be able to run Convector tests in here easily. So yeah, it's pretty much it's not a package that you're meant to use for your production application or things like that. It's just more like a testing package.
Yeah, I think that is actually really important because since some libraries of Convector can be imported directly to the browser already, but you have to do a deep linking, so you cannot import the whole package. You can import specific pieces of a package. This library, it has a different goal, right? You could still, you could have the models imported before, but right now what you can do is running things like this and having some testing code, but not necessarily, as we're saying, because you need these models mostly directly to the browser layer, right?
Yeah, that's right. That's correct. This, for example, this local storage layer, what it's going to be is telling the adapter to store things on the local storage. So if I open up the Chrome inspector and I go to the application tab, local storage, I will have all the keys that I have in store with Convector in here in my local storage. So yeah, it's mocking up and mostly for testing and development. This is pretty useful for that.
All right. So the next topic that we have for today, it's talk about the debug features, mainly how to run CC start debug and how to use CC install debug.
Yeah. All right. So this is, I think, yeah, this has been not pretty much explained yet. So Hardy right now has the ability to run the chain codes for Node.js in debug mode. So the way that you do that is by running hard install the chain code that you want to install, the language that you want to install, and you pass this flag debug alongside all the other flags that you usually pass to this command. So what this is going to do is, instead of letting Hyperledger Fabric to start up the chain code containers for you, it will actually start a Node.js server first, and then call the install and instantiate commands for Fabric. I already have this running previous call because it takes a little bit to install everything before. But it's pretty much, if you come in here, mainly what you need to do is run npm run cc package first. Run cc package. Actually, I'm going to run this in the other terminal right here. So if I run npm run cc package and I pass the name of the package, which is product, it will go and run this cc package command with the update flag. This is a new flag that I added recently to the chaincode manager. This update flag will not remove the chaincode product folder, and instead it will just compile everything and copy it to this folder without it being deleted. So what this is going to be allowed is Harley, when you run Harley install with this debug flag, it will start the server with a NodeMoon agent. For those of you that you don't know, NodeMoon is a node utility to watch and restart the server whenever it finds a change on the code. So whenever I run this cc package command, it will compile all my chaincode, all my controllers, and it will put it in here. And since Harley is running with NodeMoon, it will automatically restart the server running the chaincode, the local chaincode. So this will allow me to, for example, come in here and make a change. Let's see. On product controller, I can put a debugger in here, for example. And I have previously opened up my Chrome developer tools. You can do this by going to Chrome, column//inspect. If you go to this page, you will find the open dedicated DevTools in here. This will open up this connection, this view. And you come here and you need to add the local host, you add connection, you add local host, and chaincodes are going to be running on 9990 for the first peer, 9991 for the second peer, and so on and so on and so on. If you have multiple peers in your Harley network, it will attach each of them in a single port. And once you add that,
Diego, does this mean that when you are developing, you don't have to wait until the upgrades go and finish, so you can just continue developing, right? And you can just you don't have to worry about running upgrade again and again.
Yeah, actually, I don't run upgrade at all when I'm developing a chaincode. I just run it in on the boot mode, and whenever I make a change, I just compile it right away, and it will start the server again with any changes, so I don't have to upgrade it at all.
Yeah, that is pretty cool, right?
Yeah. This is kind of a hot reload. I'm trying to actually come up with a single command that you can actually do this on a single line of code. And whenever you make a code on the TypeScript file, it will compile it automatically and reload your smart contract just right away without you having to do anything. It's really convenient. And now that I'm on the debug mode, this is the debug mode. Right now, we're using the compiled JavaScript file. So you see this file is kind of like strange. It doesn't look exactly like the source code. But if you look closer a little bit, it will have some familiar sentences. For example, this .tx get transit value. You will find the same here. So you can come here and start putting breakpoints on whatever you need to debug something, and come in Hurley and actually send an invoke. So I will send an invoke. See, send it to transaction, and boom, it will stop in here, and you can start, like, for example, taking a look at the variables that you get. For example, this request comes with all the marbles and all the parameters that I said previously. And this is actually going to commit a block in the Harley chaincode. So it's actually a valid chaincode running. So you can, if you ever find a book that that only happens inside the chaincode per se, you can use this and 100% rely that this is going to be the same as, for example, a production environment, a production chaincode running in a blockchain.
Yeah, something that I think it's important to note in here, as you were saying, this is the JavaScript compiled version of the source code. So this is important because it shows you that Convector runs natively. This is actually JavaScript code running in the Fabric blockchain. What Convector did was using TypeScript, which is a super type. If you are not familiar with it, it's an increased set of tools, but at the end, it compiles to JavaScript. It is always JavaScript. So if you have this code base, you could change it. You can apply any kind of improvement without necessarily depending on TypeScript or depending on Convector itself, right? So that is something that some people are not aware of. Convector is not a programming language, it is a framework, and it is built on top of TypeScript, which at the end is just pure JavaScript. But as you can see, Convector looks way more elegant than this compiled JavaScript code.
Yeah, correct. Yeah. And yeah, if you actually have any doubts about how Convector works underneath, you can put a breakpoint in here. For example, I'm here in a model that's safe, and you can step into and inspect what we're doing inside of it. Well, you can actually check all of this in our GitHub. It's open source, right? But you can follow the flow in here and making sure that we are not doing like anything weird inside the framework. You can make sure it's actually using the all the Fabric client helper and the Fabric client SDK. So it doesn't do anything like strange underneath. You can inspect all of these with the debugger, and you can go deeper until it sends the request back to the peer.
All right. Yeah, I think this is pretty much it, right, on debugging?
Yeah, I think. Yes, pretty much that.
Yeah, we have other topics around here. Here's another one, which is, why did you choose this way of managing identities in the identity example? So yeah, I need to go deeper into this, and I want to explain the pattern and why we are choosing to do this. So in Fabric, we have two components. We have a component that is called a certificate authority. So in a production environment, you actually handle identities like that. But a certificate authority is not a Fabric-specific concept. It is actually a really widespread and common component that what it does is generate certificates from a seed. So you have a first certificate, and from that one, you can generate children certificates. In that way, you end up having a whole tree of certificates. So this component is completely off-chain. But the blockchain itself, it depends on these certificates to do things like authentication, authorization, cryptography, signing, and hashing, and all of that. So these are completely separate components, right? So even if the blockchain is built with these cryptographic components, it is not aware of them. It does Walter's identity is
Hey, Walter.
whether or not the relationships are
You're breaking.
Yeah.
You were breaking a little bit the last 30 seconds, probably. You were breaking up a little bit the last 30 seconds, I think.
All right. So yeah, we have this component which is separate from the blockchain. So the only thing that the blockchain knows is whether or not the cryptographic links are met, right? So at the end, what the blockchain does is just enforcing things, but it's not aware of things. It doesn't know who is who and who should be doing what. It only knows that if you tell, is this certificate related to this one in some way, like this is the parent of this one, it enforces that, and that is it. But it doesn't actually know names. It doesn't actually has the database of users. On the other way, we do have a database of users in the certificate authority server. So the parent says this: once you create a user in here, you have to somehow reflect the name of these identities or the concept of these identities somehow in the chain code. Because the chain code, as you may already know, it's a separate state. It's a separate ledger. It's a store where you put data. So if the blockchain chain codes, they cannot go outside of its context to make queries. So it has no way to go to the, for example, in this case, to the certificate authority and connect to the database, because this is outside of the blockchain. So this is a container running separately from the chain codes. So how the pattern works: you can create certificates and create users in this certificate authority. You can issue the certificates and create the names and all of that, and then you reflect them as models in the chain code. So when you reflect them as models in the chain code, other controllers can reference to that data. So this is creating a lot of benefits, actually, because how these things works is you usually have an identity, and the identity has a certificate. So if you assign things to just a certificate directly, you will be locked that if the certificate for any reason has to be removed or has to be renewed, it will change, and therefore all the links that you have to that certificate will be lost, right? So when you actually have the identity model, and you can have an array of certificates in which just one is the approved one, you can, from the certificate authority, generate a new certificate or renew this certificate and just update the link that this model had. So this model and this controller for identity, which is usually called participant controller and participant model, is what you reference from your actual code. So let's move away from the certificate authority, leave it around there. Let's have the chain code, and you have your actual logic. Let's say you are tracking products or something like that. You can make validations and connect this to the ID, and the ID has a connection which may vary to different certificates, and this is the fingerprint that you are referencing. So in this moment, the fingerprint may be 1, but tomorrow it may have needed to be renewed, and now this fingerprint is B that came from the certificate authority. So the chain code that was referencing to that identity, it won't break. It will continue to have the right connections because it is actually not referring to just one certificate. It's referring to a new concept. So that is the reason why that pattern exists. It's because there is no data when you create your smart contract to somehow reference these identities. So you have to create your own store of data. You have to create your own, let's say, a directory of identities that you can handle however you want. So for example, you may also make cryptographic validations. You can still check a certificate that is coming from a transaction, and you can see if this has some specific attributes. For example, if this account is an administrator, or if this account is from this parent certificate, you can still do those things. But the great value is to have a business concept over identities, over participants, because otherwise you will be just referencing certificates, and if the certificate for any reason gets removed or gets renewed, you will lose, and you will start having these loose links. Yeah. So hopefully that explanation can help you better understand that has.
Yeah. I think we lost you, Walter, for a second. You there?
I'm here. Can you hear me? Hey there.
Yes. Hey there. Waking up a little bit. Yeah, but anyways, so a good benefit that I see, a good benefit that I see also from this pattern is to advance it a little bit more. Is that you can probably have a use case where a single identity or a single participant inside the chain code could be able to be managed by multiple persons or multiple identities in the real life. So you can involve this identity pattern that we have existently. Right now, it has an array of identities, and one of them is going to be just valid at the time. But you can pretty much mutate that and just put a logic where all the identities in this array can be valid. So for example, this will allow you to have certain administration groups. For example, inside your chain code, you can pretty much define a participant, which is an administrator, and this participant is going to be managed by multiple real-life identities, like multiple users being a participant, like, or acting up as this administrator group. And with this in mind, you can start trying to mutate it and update this identity pattern in really convenient ways for your use case, actually.
Yeah, and I think that we can release some news for today. For example, we have been thinking of creating reusable libraries. This is something that is quite new. This is a really raw idea, but in other smart contract platforms, as Ethereum, you have libraries that you can import, and you can bring some patterns directly to your code. In this case, we believe that the first one that we could create is this pattern for different ways of handling participants. Like the example that Diego is giving, So we may be releasing a package that you can just import, and out of the box you can have this participant pattern. So you don't have to copy the code, you can just import it, and you can get it right away without worrying about updates or security breaches that may come from you copying and pasting the source code. So that is one thing that we have been thinking about and we have been discussing in the chats. So yeah, probably you will get some surprises around that specific pattern.
Yeah. Also, let us know if there is, for example, a specific pattern that you might be already created before, and you want to bring it to the table and very contribute it to the community, so we can all share this same code.
Yeah, I think we have two extra questions. The next one is, what is the benefit of splitting into multiple chain codes? All right, I think, and it also has a question about endorsement policies. So let's break this down. The first one is about multiple chain codes. Probably what you are referring to in the question is to have multiple controllers or multiple packages. So pattern in which if you have all your code into a single unit, let's say just one controller and one model, you will end up with a really huge code base, because in real life projects, you will have a lot of functions, a lot of ways to map the logic of a model, like structures and tokens and things like that. If you just have one of each one, you will end up with a really big file that is going to confuse the developers, and it's going to make the code unmanageable. So it's usually a good practice to break things down into more digestible units that only care about why they should care, what they should care. So this is about a pattern of responsibilities regarding the pieces of your code. So I understand that your question is about multiple chain codes, but I believe it's actually about multiple controllers. Because if you have two separate chain codes, they don't usually communicate with each other. They are isolated. They usually live in their own world. Even if they are in the same channel, they are separated. So what you see in our patterns is that we have multiple packages. So we may have a package for participants, and we may have a package for person, for example, or a package for products, or a package for identity, or something like that. What we do is that to package that bundles them into a single smart contract. So when you are coding, you have separate units, which is really useful for you to follow a separation of responsibilities. But when you deploy, you don't really care about that. You just really care about things being able to talk to each other. So we take them, we use a file that it's called the chaincode.config.json that is in your root project. We reference all of these controllers, which may be thousands of controllers if you want it. So for your developers and for your team, it is easier to maintain all of these pieces, because every single logic piece handles just one thing, and one thing well. And then when you need to merge them, you fill this JSON file, and it's going to bundle this into just one chain code. So you could have controllers, for example, multiple controllers in the same package, or you may have multiple packages with multiple controllers. But at the end, what really matters is that you bundle them. If you bundle them, at the end, when you install the chain code in your blockchain, it's going to bring all this logic together into just one chain code. So that is the reason. It's mostly for having a healthy code base to be able to scale, because when you start, it's easy, right? You just have a few functions, a few models, and that's it. But when you go and you start growing your code base, it's actually getting much more complex. So you can see that this week, the code base for a project that Instamet is building for the FIRE financial standard, it has multiple controllers. You can see the benefits of doing these things. As you can see that there are, in the same package, we have multiple different controllers. And I believe we have also a separate package with just one controller. But at the end, in the config JSON, we bundle them. We say, I want to pick this, and this, and put this together into this chain code. and then you deploy this as a single coordinated unit.
Yeah. Having said this, though, you can indeed has multiple chain codes if you need to on an application, on a single channel actually. The preferred way for Convector is actually just to bundle controllers in a single chain code, because you don't really want to mess up with all the handle different chain codes. They all have their own ledger, for example. They're all state number, for example. The benefits that I will say to have multiple chain codes will be just that you can track each. When you install a chain code in Fabric, each of them will have its own IDs, list of IDs separate from one from the other. So multiple controllers or multiple models inside a single chain code will share the same namespace of IDs, for example. But if you have multiple chain codes in a channel, each of them can have the same ID and have different values for each of those IDs. But those are, I would say, those are for more complex scenarios. I would say better thinking controllers first, and split up the logic in controllers and package that in a single chain code. And only if your application is like huge and for some reason you have to make two chain codes, this will be a case that chain code A and chain code B doesn't actually relate at all in a way. Having said this, actually, I'm working on an inter chain code adapter, so you can have and you can make transactions, or inside a controller, you can call another chain code being started in the same channel or even in a different channel. This will apply all the policies that Fabric has for this. For example, that it has to be a read, and this other chain code invocation cannot write to the ledger, for example. But we are in the process on dropping up this feature real soon. I think actually we released our roadmap recently in the new doc site, and this is a topic in the new roadmap.
All right. So there's another pretty open question, which is to go a little bit deeper into endorsement policies. So endorsement policies are really a whole topic. So maybe if you could be a little more specific, we can talk about endorsement policies in the next call. But yeah, we really need to know what you want to know about this, because it could be complex regarding what details and edge scenarios you may handle. And the last question for this call is, I believe that the best person to answer this is Diego, and this is about best practices regarding complex types, how to manage lists, how to manage dictionaries, and some choices on regarding FlatConvectorModel, and why we keep, for example, the the field type in this model. So Diego, you may be able to talk a little bit about good practices for nesting objects and handling things like lists or dictionaries.
Yeah. So think about when you're thinking about the structure of the data on how to handle this kind of complex types. You can pretty much apply the same logic that you apply, for example, on non-SQL databases. Sometimes, and depending on the business logic that you have, you want to store references in your models to point to something else. And this scenario will be somewhere that you have model A that relates to model B, but both of them can be updated separately, and you want to always then to be kept on site. So when you have this kind of a structure, you will probably most likely to use IDs inside models to reference to each other. For cases where you actually more concerned about the integrity of the data, you will probably want model B to be stored inside model A per se. So in this case, you will use a FlatConvectorModel, as I shown on the beginning of the video, to actually have a copy of the data at the point in time where it was saved. So it doesn't matter if you save this other model separately with a different ID. in the root ledger, for example, you will always keep the version that you store nested in the model A the first time you did it, unless you go lately and update this. But yeah, so pretty much as it's not an anti-pattern, any of those. Those are pretty valid use cases. It just depends of what the needs of your business and or your application is. Uh, to handle complex types, you can make use of Job a lot. So in examples, we use Job, for example, making validations for strings or validations for numbers. But Job is really powerful. You can pretty much use it for whatever you need. If you need, for example, to store an email, for example, you don't really need to just adhere to the Job.string value. You can actually Job has a validator to check if something looks like an email or not. So you can, for example, use Job.string email, for example, or you can pretty much pass regex validations and things like this. Those I will say those are the good patterns. The anti-pattern for this will be to make the validations yourself in the controller, because at the end that's what Convector tries to solve, that you don't have to do necessarily validations in your controller over and over again. Instead of that, you can just define the validations of how the data should look like in the model and rely on that when you're saving the data. If you're going to save something that doesn't look like what you specified in the model, Convector will reject the transaction and will let you continue with that transaction. So, was there another question regarding the best practices?
No, I think that was it. But I think I can highlight some things that you said, that it's the same principles as an NoSQL database. At the end, we pretty much have a document storage in there. We have a key and we have some data inside. So just like you will design a MongoDB, for example, you could design this data storage. And as Diego was saying, I believe that you put it really clearly, and it's really a way to decide which way to go. It depends on what you want. Sometimes you are in a regulated space. You may be following, I don't know, some standard like an ISO or something like that. And the ISO may be asking you for some specific structure. It may be asking you to have all the models nested. But in other cases, it may be effective to just keep a reference. For example, in the participants pattern that we have in the GitHub, it's actually a reference what we keep, because the identity to be nested inside of the model. I think that's pretty clear. A really concise way of thinking about handling these data types.
All right.
So yeah, I think those are the questions. I know, Diego, if you want to talk about something else, we have a few minutes.
Yeah. So we were planning a little bit of our changelog for coming months. We have some already interesting topics in the documentation. What I really interesting on here in the community here and what they're expecting to see in Convector. I actually want to see how Convector is helping them right now. Well, we already see that in the community for some comments, but I really want to know what are the pains of the community and what we can help them fix them right away. So, for example, just to give you guys an idea, private data was a feature request from the community. We had that planned, but not in the short term, but it was being requested very often. So we decided to move that on priority, and we ended up in the last release wearing some shortcuts for that. I thought you could use private data already on Convector, but we wanted to make it easier. Right now, we are thinking on this inter-chaincode communication. We're thinking on direct relationships. I'm planning to add some decorators to make really specific when you are using a relation by ID, or you are actually copying the data, for example, with this FlatConvectorModel. I'm trying to make that more clear. But yeah, I really want to know from the community what they really want to have on the next version.
Yeah, and I can tell that if you go to docs.worldzero.com/convector, you will see the roadmap that we think that should be for the upcoming versions. So if you have another idea that is not in there, and I can show my screen just to highlight this. It's a really simple list. We try to keep things as simple as possible when we can. So I'm going to show you about this. Let me see if I can share my screen right here. There you go. So it says, yeah, there you go. So
Yeah,
here I have the docs. So in this case, you can go to roadmap. And as you can see, this is a completely redesigned website. It has, just as a quick overview, it has an easier way to get started. If you want to know about Convector, about Hurley, if you want to dig deeper into Convector, for example, you can go here and learn, and you can go to the practical tutorial that we were talking about, in which we have the smart contracts and the API and so on. So if you go to the roadmap in here, we have this set of features that we believe that should be, can you hear me, Diego?
Yeah.
Okay. Oh yeah, you got in mute. Sorry. So yeah, we have this list of features that we believe that are needed. We have been adding some that the community has been asking for example, paging capabilities, some things that are much more advanced that you will need in the future. For example, handling MVCC conflicts or composite keys, or some different things like cross-chain code communication that Diego was talking about. So we have this list, but if you have any idea then that you can add in here, or if you want to develop one of these features, you can let us know. Convector is a community project. It's completely open source, as you know, and we have developers from Italy, UK, India, the United States contributing code, and just the smaller things are helping us. So for example, if you want to make a quick tutorial, or you want to translate something, or even if you want to go ahead and solve one of these challenges, it's really helpful. It's helping the community, it's giving back. So yeah, this is the basic idea that we have of features that is needed, at least for Hyperledger Fabric, while we are also providing some support, and we continue to design for other blockchain technologies as well.
That's right.
All right. So I believe that we do not have any questions in the chat. So I think we can wrap this up. It's been a really productive conversation. I hope that you could learn some new things today. So again, you can post your and
What? You're breaking up.
examples easy. All right. What about that?
I think now, yeah.
Yeah. All right. I don't know what's happening today. The last time it was really, really nice. So yeah, I was just wrapping up, telling you that if you wanted for us to talk about some topics, let us know in the comment section of the YouTube video or in the Discord. Actually, some people have been asking in the YouTube channel, and we also can help you in there. And if not, see you next week with some other topics, and hope that you can continue to build your solutions with Convector and the whole suite. So see you next week.
Awesome. See you guys.